Please, let's concentrate.
The afternoon session. This is still morning. All right. Why are you going very far from me? Not too far. I don't want to shout. Come on. Come on. Oh, you are good where you are. Fine. Haja, more people are coming. Okay. So, okay. This is AAI 102 Introduction to Deep Learning. And then the first time you people had Introduction to Artificial Intelligence as a whole. And I know that you people are sufficiently grounded. Hello. So, like I did with the last class, I will just introduce myself, where I'm coming from. And that's because we are still trying to source for members. And so I am actually from the Collaborative Center for Artificial Intelligence here in Cosmopolitan University. And just so you know, this school thrives on this technology and digital technologies generally. We try to use it maximally to prepare our students because we do not want them to be left out in the scheme of things in the current world that we are in. And so we want them to be well equipped at the end of their learning journey so that they can adapt and have an edge when they go out there, whether into academia, into business, or into government. And so we have a dedicated center here. I'm from the center. That's me. And just like I told the last class, if you want to okay, but as time goes on, same with our virtual learners. As time goes on, when we have met the quota we want to meet, we will ask you to pay to be a member of the center. So the window is open now. Take advantage of it. So that when we have trainings, programs, workshops, seminars, webinars, sessions, like information sessions and all that, and even most of our research output, you will be a part of it, not just a part of it, you'll be able to collaborate with us and be first partakers, even in getting the information about this. Are we okay? So you now know about our center. And so this course is, sorry?
Is it the CCAI?
Yes, CCAI. You've heard about us?
No.
Okay, you saw it there, all right. Should I put it up again? It's called CCAI, Cosmopolitan University. We are having a temporary location in the library upstairs, so you can pay us a visit when you are chanced and talk about your research. We can assist you with research. Okay, so let us proceed. What are you going to learn in this course? So we'll go straight into the course. How was your introduction to the AI course? Good, right? And so I started by telling you last class about the different branches that we have in artificial intelligence. And impressively, we were able to tell me most of the branches so that we do not just run with what I see a lot of people that come to the center and a lot of people I interact with, they run with. When they say artificial intelligence, the first thing that they talk about and visualize and conceptualize are robots. That's not a lie though, but that's just one branch. And this course, we are going to be looking at another branch of AI. So all these work together before you can say artificial intelligence. Okay? So, can you name a branch? AI, one of the branches. I just talked about the first one now that is so popular. People talk about robots. So we have one major branch, which is robotics.
All the branches have like healthcare.
No, that's an application area. It has 5 major branches. So let me limit it so that we know what we're doing. Okay? You can apply the healthcare. Robotics can be applied. Okay? But we have 5 branches. Good. That's a cheat one. No, I don't take that. Okay. Machine learning. Robotics. Reinforcement learning. I know. You're going away from the introduction, so we are still doing introduction. So when we get there, beautiful NLP. I like to call it NLP. It's an aspect, it's a kind of offshoot from so there's I want you to
Machine language.
machine learning.
Machine learning.
Natural language processing. When you say machine language, you are going back to assembly language, programming and all that. For the computer, okay, I'll read them now. Okay? All right. Do you have a background in computer science? Zero background. You do. How many of you have a background so I know how to relate? Okay, you have background in computer science. Okay, so don't worry, I'll know how to read my content so that everybody will be on the same page. And so we have 5 major. There are other ones. He talked about, what did you say? Where you are going? Because this one you're just accepting. You don't want to say, hello, ma. Can you hear me? Why is everybody tilting to this side? I don't look into this right. No. I'm normal. So please call Tita. I'll put an usher there. Come on. Please.
I talked about it and said before was an application which was software. Then I talked about
Reinforcement learning, and all that. Okay, so this is introduction actually, but by the end, introduction to AI, introduction to deep learning, and so forth. But as we proceed, we begin to go into those areas that you talked about. But that's fine, you can just take that and we can talk about it later. You're welcome. We have 5 major branches that have aunties and uncles and sisters and brothers, which will be same as time goes on. And then further down the tree, the hierarchy, you'll not be seeing third cousin, eighth cousin, and so forth. The first one, like I talked about, robotics. That's the branch, the major branch of AI. You have machine learning, like somebody mentioned. You have machine learning, like somebody mentioned, and then you have deep learning. In the last class, somebody mentioned deep learning, another person mentioned neural networks. And then somebody already mentioned NLP, National Language Processing, and then the final one, which is very key, of the design of AI systems cannot work without that, or a knowledge of that. It's what we call our fuzzy logic. F U Some people will say ZZ, ZZ. Why? Please, you can check that. Every of these branches, while I'm talking, please, you can go ahead and be researching it. And use Google, you can use only AI too. Let's say AI is our experts in generative AI is here, so you can help with that. So you can check this, which is very good. Hello? Are you? So these are the major branches that we have. And we are going to be talking about one major branch. And that's deep learning. I told you earlier. I said somebody mentioned deep learning and another person mentioned neural networks. And sometimes some people think they are different, but one is a result of the other. There is no way you talk about deep learning that you don't talk about neural networks, because deep learning came from the concept of neural networks. Neural network is almost like a product of the deep learning aspects of artificial intelligence. And so we're going to be starting by letting you know at the end of this, I like to call it this, I said what you will learn. But if I want to change it for you, and we are doing everything for you, all for you, what you will learn. But at the end of this class for today, what is our the ideas project, what is our learning objectives for you? What do we want to achieve in you? And what are you going to get from us? That's why we put it here, what you will learn. The first one, we are going to pick this first two. In subsequent lectures, we are going to deal with the rest. But at the end of this learning, you should be able to describe the differences between machine learning and conventional learning style. You know, I don't really feel safe in this class. He knows why, and he's smiling. It's not you. Sir, this is your glasses. I'm not able to relate. It's as if there's SSS in my class. And is that maybe it's really nice. It's okay, you can go. I just wanted. Sorry. So I'm safe. Anyway, that's just a digression. So we want to be able to describe the difference between machine learning and conventional learning. And secondly, we want to understand, I would say, the origin.
Sorry. Quick one. You said that I was going to be much. Just you say that the healthcare application, it has other things that have comments. So that means each branch that you mentioned, because it's kind of possibility has something attached to it.
When they say branch,
So it's a branch here.
yeah, you know, the wording, I'm kind of struggling with the wording here. You are saying attached to it. Let me see.
Each branch has like branch out. That's what it is.
No.
And
See.
something like that.
Okay, let me see if I can understand what you're trying to do. You are saying that each branch have different nodes.
Yeah, you said something like that.
Yeah.
Earlier.
Yeah.
So now my question is, it's like that. NLP is branch. I've seen cases where it's kind of going like in a way.
On that dependent.
On that depending on the way they use.
Okay, on that deep learning.
Yes. Should it be a branch? Kind of fun. I don't really. If it should be a branch, then that should also be a branch.
I like where you are coming from, and I hope everybody is listening to what he's saying. I mean, you are saying that these are different branches, you are looking at deep learning, and then you are saying that it has other branches. Why is deep learning not under?
No, I say no.
Why natural language processing?
No, on that.
On that.
Yes.
Deep learning.
And it should come out of that vision.
Computer vision should just come out and then, you know,
Because it has its own vision, like image transformation, image recognition, stuff like that.
image recognition and so forth and so forth and so forth. Beautiful. Now, I hope I'll be able to capture that question, and I know where you're coming from, and I think I know what you're trying to ask. Okay? Now, what you said, these branches, you are saying that there are different branches, and then they have sub-branches, they have other things that they operate. Why is this one not this? I hope you know. When we say AI have different branches. Ma, what is your surname? Sorry, woman, are you okay if I ask you questions? Are you okay if I ask you questions? Okay, what's your surname?
Umar.
Umar. Okay, you're married, right?
Yeah.
Okay. You've got children. And the surname, that's the surname. Sorry. Let's say you have 5 children. And those 5 children, are they all connected to Umar?
Because my son is Umar.
Your surname is Umar.
Yes. And their own son is Umar Fatima.
Oh, your own surname.
Yes.
That's your maiden name is Umar. No, your husband's name is
Yes, Ahmed.
Ahmed.
Yes.
Your children are all, please say me. Your children are all Ahmed.
Yes.
Every of those 5 children, let me say you have 4, okay? Every one of those 5 children, for example, are they different? Is there any twins? No twins. Are they on their own? They have their own character, they have their own mannerism, their special traits. Do they have them? They all have them.
Yes.
But they're all in the same household.
Yes.
They are called from one family.
One family.
And when they say Ahmed, you are an Ahmed.
Yes.
And you just know, maybe they have a kind of similarity. But they are all different branches of one root. That answer your question. There is nothing about these branches that is mutually exclusive. I hope you know mutually exclusivity. That is on its own. It does not have a connection. There's no way. Name your first child, please. I hope you don't mind. You're pretty inside. Halima. This, you can't tell me the blood running in Halima is not running in number 5. You can't tell me. So you can see, do you see where I'm coming from? They are different branches, all right, but they are all having, they are all, yeah, there's something about them that when we proceed with this particular course, you will understand. That's why we are starting the traditional, conventional programming, which we tend, just like one of us mentioned in the last class, it's called the traditional programming style and method, and then the machine learning. Yes.
Let's just say it's like a hive. Is that
Yeah.
a beehive between the guards and the workers?
Stick with me to the end of the course, and then you'll see that a diagram that I captured. That's just like this. And then you get this one. Now, but don't step ahead. Okay, so if you describe, we're trying to describe the differences between these. That is why there's no way. If I just go, I'll just come into this class and say, okay, fine, deep learning. And so we go into, and then you do not have the background of how we got there. What are you learning? Something about the foundation, right? Okay, and so that's why we look at that, those differences. I hope the people that are learning virtually are understanding what we're trying to say here. And from the questions, please pay attention to these questions.
Those online are saying they can't hear anything.
Can you please You've been in class before. Is it okay if you can talk to? Oh, sorry, Mr. Wanda is here. Sir, please, if you can tell. She's here. All right. Can I just move it?
Okay, let me just.
Is it a generic
Let me
problem?
monitor it.
Okay, sir. Let me just hang on a bit so that, we'll be on the same page, so you don't have too many people typing. They can hear now. I didn't, okay, so that I don't go too far. I complained from the beginning. I said they were too far from me. It's them, it's not my fault. It's them. They went too far. Okay, I'll try and stay close. Okay. There is actually no way we can talk about deep learning without understanding machine learning. And then from that understanding, we will understand why we now said, okay, fine, no longer machine learning. Let us go further into deep learning. Why machine learning is still there. But it is, if I use the word, which is not actually exact, but you can say it's an upgrade of machine learning. It's going further, no graduations, just like when you talk about the conventional programming. Let us give this example. A programmer wants to develop a software to immediately pop up a reminder icon when their computer is turned on. There's not, how many of you have configured your system, your computer system, so that immediately you finish booting, you see Wikipedia or some other sites? Some people do it. A site just comes up. You want to, or just maybe the news site, CNN. You want to listen to the news before you settle down for the day. Say you are a programmer, and then we'll bring this example. If you were to write a prompt, you say immediately pop up the reminder icon, blah, 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 blah. And then there are two things I want you to see there. I want you to see the input and the output. Input and output. And so the first one says the first step that we are looking at the traditional method that we used to know, we have used for years. The good news, let me just tell you the good news. Everybody worldwide, we are almost at the same level as far as AI is concerned. People are still exploring. And from your last class, you understand that AI is not new. By way of application, most of us are still exploring and trying to find out new things. In fact, there's a conference coming up, which we are going to be hosting, the Collaborative Center. And it's actually zeroed in on context-sensitive innovation, a kind of innovation that is local to the African community. Because most of what we know is Western. And I hope you know that the VC of this university is a professor in artificial intelligence. In fact, his specialty is artificial intelligence testing. So check him out, check him online, read about us, read about other people, and you see what he has done extensively. So you are okay. So you are free to bring up new innovations. You are doing this at the right time. You are not left behind. That's not to say that AI have not existed since. From the last class, you know about the history of AI. But what we are seeing now by way of the applications and the outputs that are coming from AI, it is evolving. And it's a very good time to jump into this train. Whatever you're doing, whatever discipline, whatever vocation, if you do not know about this technology, you just might become irrelevant in the scheme of things. So you're welcome and well done. A programmer wants to develop a software to immediately pop up a reminder icon when their computer is turned on. Traditional way. The first step is to develop the code that performs these actions. You develop a code for it, right? How do you develop the code? You write, you come up with an algorithm, and then you feed it into the system, you run the code, and what is the result? The second point there, the pop-up icon comes on. So anytime you put on your system, you see the pop-up icon. Do you know what you're supposed to see? Do you know what you're supposed to see? After writing that code, and then when you put on your system, do you know what you're supposed to see?
Yes.
It's what you told me.
Yes.
The pop-up icon. Maybe that pop-up icon is reminding you of your anything, like your water. What do you like in your hands? You don't know. Or it might remind you that set an alarm for this, or you're having a meeting, or your son, or bring up a to-do list, whatever that pop-up icon is, whatever message is, that is what it will do. Who determined it? You, the programmer. Who designed the algorithm for it? Who has the expectation? Who knows whether the expectation is on point or not? That's the traditional way. That's what we know. And so there was this popular saying, garbage in, garbage out. Whatever you feed into it, that's what it gives you back. And so you take what you get. Right? Fine. Now, we moved on. The machine learning development style. And you know, there are a lot of thinkers. And they're like, why should it be like this? There's a group that had a program when they call themselves the disruptive group. When they say disruptive, you know, people always think of they scattered everywhere and broke everywhere. No. You know, they broke the rules. They try to change the trajectory, the likes of OpenAI boss, the likes of Elon Musk. They don't think the way the normal human beings think. They want to improve things. They are not satisfied with the status quo. At the back of their head, there's always more. They're hungry for new things. And at the back of their heads, that's why you're in this class. You should always think that we can do it. We can do this thing. We can change the way it is done. That's why this change came. And what is the change about? It says a programmer plans to develop a software to predict which students will come to school late. You can see the way they are thinking. They are not thinking, okay, let me just calculate, 1 and 2, and then we start going chronologically. But this time around, how can I predict? And we had a beautiful debate in the last class about if it's just us males. How many ladies do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine, 9 of us. We know who is the habitual listener, don't we? We know who we call English. We know who will give the key to. But when you have 3,000 ladies, well, 3,000 is even small. You can count. With 3 or 5 people, we can know, right? 300,000. You need help. Sure, you need help.
Yes.
And so you want to do this. You want the programmer. No, a programmer plans to develop a software. And so you begin to think of, how do I solve this problem? How do I know? So that I know what to prepare. I know how to prepare the space or whatever you want to do. And then the first step would be to identify all the students and their attendance records. And then the next step, then look at their history. You are looking into their history and you are recording their history. And by history, we are talking about the time they came, the frequency. That will come into the not just the frequency of their coming. Somebody came late, and then come early. You know, they're just like, you are bringing in all that data. And just like I asked the last class, what does AI feed on? What's AI's food? Data. And you see the massive amount of data you are collecting. And what are you doing? You are feeding it into the machine. That's you are telling the machine, learn from this data that I'm giving you and predict which student will most likely come late. Okay. Predict which student will come to school late. And then you leave, you are telling you are the one that wrote the program, and you put it in the machine, so the machine can now begin to use the directives and begin to predict which student will come late autonomously. I hope you know that's machine learning. Of course, from your last class, you already know that's machine learning. The machine is learning from the data that you fed it, true of us. And what is the developmental pattern to that? The first step would be to identify all the students, their attendance records, look at the history, if they come late or not. Machine learning is then used to produce a model that predicts which students could potentially be late. And so one thing I highlighted there, the first normal way, the conventional way, you have input, output. Okay, let me just take it now. The traditional way, you have input, you have set of rules that you give to the system, and then you have your output. With most of the time, you know what the output is, a pop-up icon. If you don't see a pop-up icon, you see a lady dancing. Hello. You know what I mean? So the next one, look at it. There's a change. You've got input, you actually have output, and then the machine is now setting the rules, telling you that from this output that I got from the input you gave me, from the data you fed me with, and from this output that I'm getting, these are the rules. These are the students that will come late, that are most likely going to come late. These students will come late based on this. If they go further, that's why we are going into deep learning. When we go into deep learning, they won't just tell you. When they give you the rules, you yourself will say, is this a machine or something? They will give you analysis of why they think this will happen and that will happen and that will happen. That is why you're in this class, going through this. So let us just go through what we have just discussed. We said for the traditional programming method is manually built by the programmer, manual. And then we adopt a rule-based approach. You set the rules for the system to work with. And then we have it predefines an outcome of the program, which we have explained. It is outlined by a set of specific rules and functions, and then is yielding specific results, expected results. What you know, that's what you expect. And anything outside that is an error. It flags an error in the system. And so we go through the next one. In a nutshell, you have the ability for the computer program to learn and adapt to the data that you have fed it with without human intervention, and use of built-in programs and algorithms to process high quantities of data that provide what? Reliable predictions, reliable ones, and then identify patterns within current information. Let me give this example on this place now so that you have an understanding. So when we talk about reliable predictions, what if when you were feeding your machine with the data, you included the data of some teachers? So we are still in machine learning. You included the data of some teachers. Are the teachers coming to you? Yes. The names, and among the names, some of the teachers are there. And you didn't put student, but you specify student and teachers. You get it? The machine, and then you tell it to predict for you. Sir, can you just tell me what it will predict most likely? Yes. You didn't hear me? Oh, I'm not loud anymore? Okay, no problem. I'll Mark, what is the machine most likely going to predict? Will it? Okay, if it's giving the result, that's to tell you. It can tell you that some He can. You want to say something?
Regards to the teacher doing
Yes. In the data set, you fed it. You were the one that gave the data, and then you tell the machine. Know that in this case, it's just one machine. It's machine. I mean the basic machine learning. It's not machine learning. You are not at the deep one. Okay.
the output is to be it's to give an output based on what you gave. It's not
So
to-
among the predictions, it can give you that this set of people are most likely to come late, and most likely some of the names will be teachers' names. And what was the instruction? Students. But whose fault?
person that provided.
The data. So that's talking about the kind of data you should feed your machines. And that's why we are doing this course, because we are going into deep learning. Now, do you know you can actually feed it with student data and feed it with staff data? And with deep learning, you separate the two. Do you know that? So, but let's stick with this one first. We are moving, so we'll get there. I think we've discussed this. We talked about, from what we have been saying, we talked about this input and desired output. Remember this. Input, output, and rules. Okay. So, and then functions that we are trying to learn, and then the predicted output, and then loss function. Like I told them in the last class, most times when you are trying to run a process, even if it's just most times we talk about digital process, of course, we talk about digital technology. So if you are running the process, before you settle down with the final result, you get what you call feedback, right? And this is like synonymous, it's not the same. There's a synonymous to feedback when we talk about our loss function. What do we mean by loss function? We always want our loss function mathematically to tend to zero or to be zero itself, which means the predicted output is exactly not, I won't use that word. You know, we're kind of like careful when it comes to AI, because you see that we always tend towards predicted. Because AI is a machine,
Yes, so
it's not human. There's the element of bias, and in your last class you talked about bias that can be mitigated.
yes.
You know you can mitigate bias very well. Okay. So the prediction will be almost on point.
Okay.
Really good.
Means how the loss
Sorry?
what's the loss function?
The loss function. We'll talk about the loss function. It is an evaluation that tells you that the prediction is very close to the expected. You have typed a lot of things into many items like ChatGPT, but when they give you a result, there's something you're expecting, right? You need help with something, and there's something you're expecting. You know, somebody did, okay, let me just play around with this. But get the message. Somebody came and showed me an output from AI, and then put a prompt on this AI tool. And then it was to bring a photo of a peanut. You know, and the thing brought something that looks like a dog and a cat. It's looking like a dog, it's having the features of a cat. And if you look closely, depending on which one you are really seeing, is a dog, but it's got setting, whiskers, and you know, and so you're like, what happened to the prompt? In a situation like that, the loss function is high. It's very far from zero. That's what we mean when we talk about loss function. No, by the time you want an output that is very close to the expected, the loss function is most likely going to be zero or very close to zero.
So in that situation, the scenario you just give,
Yeah.
if it is low, what will have been the expect? What will have been the results?
Your prompt.
I put my prompt because the loss function is higher than zero. I have a picture of cat and dog as one. So my question is, if the loss function was less than zero, like we're having minus something, so what will have been the results? The AI is going to be.
Honestly, I don't know. Honestly, I wouldn't know that because AI can give you outputs that can blow your mind, depending on your prompts. That is why I'm sure there's another course that will be called prompt engineering to know how. What if this person that puts this prompt really wanted something that looks like a hybrid of a dog and a cat and is guessing that, and then in the normal sense of our daily life, that a creature like that does not exist. And so I'm looking at it from that perspective, not what the person, the programmer, or whoever wanted. You understand? From a normal perspective, it's not normal to have a creature like that. And so I'm trying to use it to explain the loss function. Did you get it? So we are trying to look at our training data, and then we talked in our last class about the training data and the test data. We know that our training data is used to train our AI to be able to give us some output. But before we have the final output, we have to test with what we call our test data. And the test data is not the same as the training data. The test data is not exactly the training data. If not, your results will not be authentic enough for you to give a legit inference that this particular system is working well. True or false? So these are the things that we should have at the back of our minds as far as machine learning is all about. I know you've learned about machine learning, but when we design these algorithms, something I should know. Have you got a question?
Yeah, but it's related to the AI itself. And it has a limit. It has a limit. So the information you give it is, it's, how should I say? The output is half-baked. Let me use that word. Yeah. It just goes halfway and gives you like a slice of it instead of using the whole cake.
So what exactly is your question?
So my question is, how can you get that full? How can you get the whole cake?
If I understand, I think your only limit, the only limit I start with depends, it's your own limit. Because whatever data you put to it is what it will give you back.
Something interesting is going on here. Please, I need your attention. Somebody just asked a question that most times the output from AI is half-baked. And one you see, right? How do you get somebody is answering, which is good.
So my own point is, I feel to start, you spoke about AI has a limit. I think AI doesn't have a limit. The limit you have is you or the data that you're trying to feed the AI, because whatever you give the AI is what it will use to give you back. So without distinctive data given it, of course you're going to get half-baked. But give it a full-baked data and you're still going to get back your full-baked result that you're expecting or prompt.
Are you okay with that? Okay, let me throw light into that. Let me throw light into what he's trying to say. What he's trying to tell you, sorry, I can't go too far from the system because of our virtual learners, but let me throw more light into what he's trying to say. He's correct. Is the data, it depends what you want to see. You understand? You can actually help the AI by giving it good quality data. And good volume data. Okay, I remember in the last class, there was something that, there was an analogy that we used. Now you want to tell this young man that is preparing for the Olympics, and you want him to bring back the trophy because there's a heavy bet. Take, for example, there's a heavy bet on his winning, and you need that money badly. And so you are preparing, so it's your responsibility to prepare him for that race. And you give him snacks. He will so bring the trophy back. If he doesn't vent. Did you see the people that are there? They tell you Olympics is the next 4 years. The whole 4 years they are practicing. Every single morning, just as you dress up and come here. They don't have any other job. One job. You dress up, they go there. They go for training. And then you give him snack. Let him practice 2 times in a year. That is what you do with your data and your AI and your machine. When you talk of machine learning, that's what he's trying to explain. Now, you now give this young man swallow. But you know swallow has different levels.
Yes.
There's the one that's carrying for the old day. There's the one that's afternoon. You are now looking at anything happening. So when we say AI feeds on data, if you want some kind of AI, you know the kind of data to feed on. And then what you are saying, for you to get the full cake, there are different factors that come into play. You have to think of variables. You have to think of the kind of data, the quality of data, the volume of data. You have to also think about other factors like your knowledge of prompting. Are you asking right? Are you asking correct? That is why you have an opportunity to tweak your prompt to get the exact full cake, not just a slice. Are we okay? All right. So, these different algorithms, we have the supervised learning type of machine learning algorithm. And for this one, I believe is tending more towards the traditional, programming style, because here it said the machine model learns from the given data with guidance. So you are still controlling how it's supposed to learn. You are letting this learn like this. This is what you should learn from. The data you should learn from. That's supervised. And then we have the unsupervised. This time around, they said the model learns for itself. So what you just do is what? Feed it with the data. And then it starts to categorize and learn from the data that you have fed it with based on the kind of algorithm. Remember, it's machine learning algorithm. Depending on the algorithm that you have created and designed, how it should learn from the data. And then finally, we have the reinforced learning. And this one, the model learns to react to its environment on its own. It's autonomous. So to say, in quotes. Are we okay? Do we have any questions so far? All right. So okay, sir.
My question will look somehow because I'm a local son. I need to use the local language. What I understood is
Sorry, you are a local.
I'm a local guy which I wanted to understand AI in the local language.
Beautiful. You are welcome.
yeah. To my understanding, it's a system that will feed that information, data, current data that we want. So my question is, we have ChatGPT, right? It's one of the examples of artificial intelligence when it comes to getting that correct information. I would say have a meta. So at times we realize that the information that we get from meta AI and ChatGPT is quite different. So I wanted to know the data needs, are they different or synchronized data when it comes to machine information?
Interesting. I am trying to attempt to call a generative AI specialists to answer that question. Mr. Obi, are you able to throw some light into what you just said? Because I know that he has given some trainings to most of the use of these different tools. Why is it that the output? Because right now, interesting stuff. He's trying to come up with a comparison, because what you just said is a major concern. Sir, am I on point? It's a major concern because we are trying to compare the output. Please check him out. You can visit us in the center. There's a research that we are working on right now, and there's a research output that was presented. He presented it in one of the conferences as a poster presentation. What we're trying to do is what you just said. We are trying to find out the different outputs from the different AI tools. Why are they so different? Why are they similar? What is different about each one of them? Which is strongest? So it depends, it boils down to design. Which design is more powerful? Do you get it? And so we do a comparative study in our research. We came out with an output that we are not really satisfied with. There was good insight. Maybe do well to check us out on that, and then we'll throw more light into that. What you're saying is true, and we are working on that. And we are going to do more research on that. He's doing more research on that, and to see why these differences exist. And at the end of the day, we'll be able to recommend to people for this particular kind of prompting. This is what you should use. They have strong points there. It's like when you go to Chicken Republic, you know what you're going to get. If you go and get beef from Chicken Republic, you're wasting your time. They will give you a right, but you know where to go. Do you get it? Have I answered your question? So connect with us at the center. It's okay, sir? Okay. And so, any more questions? Okay, so we proceed. All this that we have been talking about so far, this is our target. I hope you know that this course is AAI 102, Introduction to Deep Learning. So we are trying to look at deep learning. And so we have to understand machine learning, the intricacies in machine learning that brought us here. And so if you look at this, just like I said earlier, this is a major branch in AI. But people interchange it with neural networks. But most of the concepts about deep learning came from neural network. It's actually neural networks when you talk about it. As you go further into it, we're actually talking neural network. And where did it come from? So you will see, like if you look at this diagram, I try to draw this and see that the outer part, that's just the generic knowledge, like what we have been talking about, feeding your machine with data. What are you having? You're having machine learning. But by the time you go deep into the deep thinking, when I say brain, then I'm not just talking about brain, the thinking. You know, there are some people that there's a way a child thinks and there's a way an adult thinks. I don't know if I can. A child can just say, oh my God, I just like this and that's it. And then the adult is like, oh, you like it, it's fine, but don't worry. This fire is so beautiful. Look at the way the thing is just this, and just touch it, and then the adult is like, it's nice, it's fine, we just need it. Because the adults have taught more. Is the child wrong?
No. But that's like reinforced.
For the adults.
The adults have gone deeper, you know, have analyzed, maybe have touched it at some point. And so there's some kind of learning. Like the machine, the adult is the machine. Please, anytime I tell you about learning. Please, it's digital learning, it's not our human learning, okay? The adults have learned and can use that experience to give you and output. That was why we were saying that I was highlighting output, input, and all that into this kind of learning. And so there is deep learning. And so that's why I wrote here that it refers to the application of many functions, one after another, to the input. And then secondly, this depth provides immense power to the overall function in terms of what it can represent. That is where, if you notice, if you have been reading the news about AI, anyway, anybody here or those virtually, I'm sure you are very much interested in artificial intelligence. That's why you're here anyway. You will see the concern of everybody. It's like you give so much power to a machine that hasn't got empathy, no feelings. And then you let it, did you see that statement? In fact, I actually pondered about that statement before putting it there. I said, this depth provides immense power to the overall function of a machine, not a human, in terms of what it can represent. So you have to be careful about the kind of data you feed it. Now, by the time you are using AI, those of you that, somebody told me that the mother buys things from AI, uses AI to buy things. I was like, when she said that, I was like, okay, AI to buy things. How? The AI is such a beautiful tool. When she uses it, it will direct her to where that particular product is. You've used it, ma'am. It will direct you to where that product is. You see how powerful this tool can be. And that comes to, I always like to chip this in, because one thing we represent at the Collaborative Center for Artificial Intelligence is the responsible use of AI. How can it be used responsibly? How can it be used ethically? So that it is a safe tool to use, because it can be very destructive. And then we are actually introducing it so that our students don't miss out on the purpose for which this tool is meant. It's supposed to be a tool to help you, just like it helps you to show, it will tell you the exact store in Abuja that product will be found. So you don't have to waste your precious fuel going around, say, market and some other exclusive shop. You just go straight there, or you order it and then you bring it, and you're as the member of the center, I'm just shipping this advice. Please be careful the way you feed your AI. Do you realize that those inquiries you make online is being saved? And they reuse it to also train their models. So it's not just gone. That's why you see that when you come 2 years after, you ask, you put a kind of prompt, it's giving you a certificated answer, response, because it is learning more and more, it's taking in more and more. And you put sensitive data about your children online, saying the name of Sajiko or something. There are some data you should not feed AI with. Or there's a way to feed the AI with safety. We'll talk about that if you come to us at the center. We'll talk more about that. Yes.
Why are we still looking for safety when it comes to AI? Like the whole point of creating AI was to be safe. And our looking for the ways not to be safe from it. Like it's not making sense. It made things easier. Why do we still go back and try and find a way to be protected from the same thing that makes life easier?
Well, a very popular speaker once said something. It's a common quote. He said, when the purpose of a team is not known, what follows? When the purpose of a team is not known, it's natural. It's one of the natural, it's like gravity. And so we are created to do this, and then now we are like, oh, it's overdoing it. Is that what your question? I feel you. And I know what the pain is. I can relate with what the concern is. But that does not erode the need for control. It does not, it's not a substitute for it. We can't just say, okay, fine, we created this, so we can use it like that. No. You have to have control. In every system in this world, there's the good side and then there's the bad side. If the good side is not enhanced, the bad side will take over. So there has to be control. There has to be balance. That's why some of you are in fields of cybersecurity, where you try to control how people go into the cyberspace and begin to wreak all manner of havoc. There must be control. That's why we talk about that. Did I answer your question? Yes, ma'am.
Like when you were talking about like data safety, being confident that right? Because sometimes like want to get space, I would like to make everything almost as simple as the shape and now. So even sometimes when I give information.
Somebody is asking a question that is beneficial to everyone. I know, there's a controversy going on there. Meet me upstairs. We'll discuss that. I like that. You can meet me upstairs. Meet me at the center. We can talk about that. Okay?
So there's some information that's maybe I didn't include right now. But then from previous things that they are now like possibilities
Everything about
using those information. So is there maybe a possibility of maybe one day something happened and maybe I will give them information to come?
That's what we are trying to say.
Maybe.
No, relax, fear not. Now you know. Now you know how to mitigate that stuff. And then, that's your personal space. You have to know how to protect your personal space. You get it? You know, AI, like we teach our students, AI is a tool. AI is not. Let me give this example. Talking about what you're saying. We do it. That's why you are in this class. To know how to use this tool, to know what it entails, to know what the pros and cons are, to know how to use it properly, or even how to design one that will put all those checks into place. Can even filter some things that are too, personal and all that. That's why you can design it such. Okay. When a student submits an assignment, what we try to do, you discuss it with us. You come back to us, you discuss. We will not tell you, in fact, we encourage you to use good tools, AI tools, for your research, so that your findings will be good. Then you should know what the findings are. You cannot claim what a machine gave you that it is your own. It's a lie. It's just a lie. At the end of the day, when you are sleeping, they wake you up. What is this? You're like, oh my God, it is AI. Who did it? No. So that is, you see, when you are telling it to help you do something, you have a part to play. Be involved. If you look at mitigating bias in AI, I'm sure you did it in your last class. Human in the loop. I'm sure you talked about human in the loop. A human being should be in the loop of all this exercise.
Is that cost evaluation?
No. That's mitigating bias. Trying to mitigate AI bias in different environments, especially in learning. A human must be in the loop. You should be in the loop. You don't just give everything to AI. No. Have some control, have some reserve. Especially your trade secrets.
But it's not the point for it to make things easy. And that's the point of every mission.
Yes, but not too easy.
Yes.
There is easy that becomes a problem. Too much of everything is. There is a kind of easy that now becomes a problem and detrimental to you.
Yes.
Two of us. What kind of apps? Okay, take for example, you have a trade secret. There is this, I know you are an economist. And as an economist, you're talking about the personal part. Okay, you are studying. Okay, take for example, you practice, and then you look at, there's something called financial economics, right? And then you have maybe like a firm, a company. Let me go closer to my system for the virtual learners. Are they listening? Are they hearing? And then you kind of doctor, is it doctor I call it now? You kind of analyze the financial books of some special clients. I know of this group of people I work with that what they do, they are economists and financial analysts. What they actually do is that there are there are some small companies that need to submit their audit reports for one thing or the other. They do that, right? And so they cannot go to the big five, KPMG, Deloitte, or they go to those people that audit CBN. They can't pay, but they look for good firms that can help them to audit their financial activities, and then they can present that. Thank you. They check all those things. You understand? And then you have a company like that, and you are building a company like that, and then you have a sensitive tool or structure that you use for that. That's local to the company. And if they go to another company, they don't do it as much as you do, as well as you do it. And then you put it on there and everybody sees it. You have just created competition. And you know the world is very cold out there. You will take what you have and improve it. You will run you out of the market. Two of us. Sorry?
Just like
Okay. Have you seen those cooking videos? I mean, very good ones. It's so fast, you can't pick anything. And then when you try it at home, you are cooking trash. They did not give you the whole secret. They won't give you. So you have to be careful about the things. That's what I'm trying to say. Let's listen. Okay? Do we have more time? It's going to happen again, eh? Okay. You have a question, sir?
Yeah, I think you got a question that is like, you might not understand it. Most of these AIs at times get few of the information at times. Like specifically, if you're conversant with Snapchat AI, you can ask him something. For example, from you can ask him, where can I get from this scheme? You get. He can tell you, okay, he don't have that idea, but you can contribute. So it seems like he needs more information for a future set, which I agree with you. Is there any way a government can have a policy and have the regulator around that area with safety?
I want you to keep an eye to answer that question. We are working on something. Again, if you want to be part of that something, keep an eye on our website. I'm going to be talking, I'm going to give you a presentation in a conference, and I'm going to be talking about AI ethics and governance. And we are working with government, we are working with academia, we are working with business, and we are trying to propose a policy that can be put in place. And then there's a big area that the VC is working on. He's actually working on the orchestration method of AI, where there is a structure in place that should put these things in place. And it will be accounted for. So we're going to get that blue policy. It's quite interesting that keep an eye on the page. If you want to be part of that conference, you need to virtually on the site. That's in January, towards the end of January. In case the dates are not be in that conference. And they are not doing on There are so many people that will talk on that and answer that question. But in this class, no.
But it's not the direction.
Huh?
What's the direction?
No. Cosmopolitan University.
Yeah.
Cosmopolitan University. Just check CCAI. We'll put it up when it's close to the time. Just keep an eye on the page. We'll advertise it when it's close to the time. Okay? But we are still doing a lot of work and kind of collaborations right now. Yes?
In addition, because I worry we're in time for this, because before the government will even look into AI, most likely half of the information that was not in say has already been set with AI. I don't know that you are with that like you.
But I think you're right. Well, unfortunately, we are not exactly at the forefront of a lot of things until it has gone. They will not to, but it's never too late to do right. It's never too late to do right. So we can change the landscape. But it now becomes bad if you don't know it. So let's proceed. Okay, just like I said, we are going to talk about the concept of neural networks. We're going to talk looking at the concept of neural networks. Why are we particular about the neutron of the human being? I hope you know we have tens of billions of neutrons, and it all came from that. The whole concept of artificial intelligence, deep learning, neural networks came from the concept of the human being. It's just like the aeroplane. Most of the things we see now, people have talked about, if this bird can fly like this, I'm sure the aeroplane can fly too. If we just adopt some of these concepts, so we go and study them, and then they bring engineering into it, and then you start flying. We're going to the end. Same with artificial intelligence. We look at what the human brain. How does it? Just like I put it, that's why I put the photo of that brain. How does it work? How do you now? You are now making a machine to think and produce results like a human being would. Wouldn't it just be a no-brainer to check the human brain and how the human brain works? And so you now adopt some of those concepts in designing a machine that will think like that. It cannot be that complex. But it gives you a good footing to design an AI system using this. And so we are going to now get busy. Please bring out your phones. Let us try and help ourselves. I want you to see the interconnectivity of these different neurons. Listen. Can you use your phone and search up the nucleus? You are going to speak last. Ma. Yes, you have spoken. Can you search up this? Who is a medical person here? Yes, can you be telling them? I know you pronounce it better. Okay? Soft line. Here. Say it like you swallow them. This.
Axon.
Please search it up. Just search it up. You can use AI, you can use Google, okay? Whatever to. But please, I like AI kind of. Just a definition of its function. That's what I want to do. Then, no, we're dead. This one. Can you? No, not this one. This one.
Then right.
Search it up. And then, Mark. Yes. Can you search up this? Okay. Yes. And then, sir, please, can you search up this?
Golgi apparatus.
Golgi apparatus. I said it well. Okay. Yeah. Oh, you mean you cannot see it from that distance?
Yes.
Okay, I'm sorry. Can they hear? Any questions from them? No questions? I don't understand it. Okay. All right. So, you're the last, please. The who did I say should say?
Dead right.
Who? Okay. You are second to the last. Okay, I know why I'm saying that. You understand when I say. So the rest of us, can you just say the meaning? Just give me 1 minute. The meaning of it. As in the function that it does. This, by the way, is a typical structure of a neuron. And these are the different parts. And I want to let you see how the network is going on here. Okay? Okay, if you are ready with yours, just, yes. Yes, no, just the function, in just a one sentence, just like a definition. Please, I want you to listen.
The Golgi apparatus receives biochemicals from the plasmic reticulums, modifies and sort them, and then package them into vessels for transport.
Package them. You see what it's doing? It has its own specific function, right? And what is that function?
Yeah, it's packaged for transport.
Package for transport. Next.
The primary function of which is to generate large mitochondria is to generate large quantities of energy in form of adenosine triphosphate.
Okay.
And it stores calcium for cell signaling activities, generates heat, and mediates cell growth and death.
Did you see the functions it's doing? Is it doing the function of?
Package and for transport.
No. What's your own that you did?
My function is it's packaged.
I know. What is the
Golgi apparatus.
Is it doing the function? Okay. Next. Math. Okay. No, just say it. You can read it from there. Straight up. You can read it. Okay, can we listen, please? Of a liver cell refers to a long cylinder as compared to a long cylinder projection of a nerve cell. Good. Neuron that. Okay, no, that's fine. That's fine. There's something I want to bring out here. We are looking at a neuron, and you can see the different functions that is taking place here. Sir.
Then that's the branch extension of a neuron that receives signals from other neurons.
That receives signals. You see, that's why I want you to be second to that. It's receiving, you see the signals that they all said, and all these signals is receiving all of them. Do you see it? And then you see that you see them. You can easily recognize them. It's seeing all the signals. And what is the nucleus doing? Which is the center.
It controls the genetic information of the cell and thus heredity characteristics of an organism, control of the protein and enzyme synthesis, control of cell division and cell growth, the regulation of transcription of the mRNA protein and production of ribosomes.
Control and production. And what's that production? The output. Now, there's something I want to bring out from here. You can see the different parts of the neuron to produce just one output. So it depends on when you give it a signal. You see all these activities are going on. Tens of billions of neurons. So for you to just say, my colleague, you see what has gone on? All this working together. In machine learning, deep learning, when we go further, this is how these nodes are connected. I promise you guys that when we get to this point, you will see something. Look at it. This looks like a mesh. Somebody said something that it looks like a, what did you say? I said, wait a minute. A hive. Doesn't this look like a bee hive? You can see the different nodes. These are the inputs you are feeding in. This node, they are giving different outputs and different signals. And then they are all communicating into other signals, just like the nucleus. That is how it will bring out just one output. Just one output. But you see what is going on. Like that output. No, don't touch that file. So many things have gone. So many experiences. That's talking about it in layman term. Now let us go technical. Combining many neurons into a neural network. In bracket, I said a network has one or more input values. You can see from here. You see the input values all entry to get this will now coordinate it, and then it will now bring an output that will determine the kind of signals that the other parts get. But that is the human. And you know we are drawing our concept from the human brain. Now, machine. And then we have here that each of these inputs are connected to every neuron in the first hidden layer. You will see that these layers, we call them hidden layers. We'll get to that in our next class. And then the output of every one of these neurons is connected into the inputs. And all the neurons in the second hidden layer are multiple hidden layers. That is why in the last class, to quickly round up, because we're running out of time. Oh, I still have time. So I told them, what is the deep in the deep learning? When they say deep, why didn't you just call it machine learning? Because all we have been saying, machine intelligence, it's still the same functions entering into the machine. So why are you now calling it deep learning? Why can't you just give it as machine? Let's apple the apple for goodness sake. Before you carry system and say it's apple. What is the deep in deep learning? Why did we not just leave it and say it's machine learning? Because everything that we have been saying, machine is learning. So what's the deep in deep learning? Who can just get that? I'll buy you lunch. No. You were in last class. That would be it. What is the deep in deep learning? Well, like it's close to it. Now, does anybody want to try? Ma'am? Expression. Expansion. Yes, that's a generic word. But I want it to be technical. Come on. Yeah, everything is in depth. When you say deep, in fact, this word deep in English, deep is not ordinary now. It's intense. It's extensive. But yes.
And of how each neuron controls.
You are going there.
Yeah.
Already, deep nature is basically the computation, how information from one neuron goes, each information from each neuron goes to each neuron in each layer, and then they continue.
No, you are explaining.
Final.
Yes, you are explaining this.
More the computation, and then the feedback, keep correcting, and using that deep nature.
No, that's beautiful, but that's basic transportation. This you're explaining this.
Sorry, can I use human body? So
No, don't use the human body. Use the data. Launch is at stake here. All right, okay, try.
I think for you to have the ability to think on its own without having to, for you to have ability of thinking on its own without others feeding it information.
Yeah, that's what we've been saying. How? Just give me the how. How does it do that? How does it do that? You're right. But how does it? That was deep. Why do you not say okay, it's deep? Why is the parent able to
Because I think it does that by getting information from other sources from, like, you can go on Google to get information from this.
No, because of organization. Feedback, so
Because like
You're going ahead of the class, you're talking about optimization, but before we get to optimization, you try. Yes, that's okay, okay, fine. Let's stop this. Let me just continue about it.
Now, I said something that you people are missing. Thank you.
Somebody said layers. Okay, layers. You see, what we have said so far is machine learning. And you just have this like a single layer. And so when you have multiple layers, what are you having? Multiple functions. One function, one function, one function, one function. You see function upon function. Different layers of functions. And all these functions now come together. It's not simplicity anymore. Am I saying right? So it's not simple anymore. It's not this child that just lost this fire and touches it. But you're having layers of experience, layers of engagement, different functions. You have this function working on top of this function, working on another function. You are putting different layers of functions to attain, like you explained, a complexity that I'm missing. That is why that system can actually separate the students from the teachers. Because it has been fed a layer of just the students, and then there was another layer of learning. The machine has learned another aspect, and then you put another aspect of the machine to learn another aspect. And so it's now becoming complex. But at the end of the day, just like we have these nodes all working together,
Going back to this,
they are all working together to produce a single output.
Yes. My question.
Yes.
So, from this picture, what is the layer? I mean, you can see that the circles are mirrors. So it's a layer like one column.
what is the layer? They are the things you want to do. So this,
Interior, like I'm looking at this now. What would I say is a layer?
Okay. This is a layer.
Yes.
This is another layer. This is another layer. And then it's giving you an output. But look at something that's beautiful here. Look at
Connection.
the connection is wow. That's what's giving almost like a beehive. You know, that mesh kind of thing. But this is what intrigues me personally. I don't know if it's going to intrigue you. Do you see the way the analysis took place? The machine learned with all this, and then it's narrowing it down. Do you see that from all this? See, from this layer, you see how many is feeding it into this one?
Yes.
You see it's feeding it into this one. It's sucking in all that data and learning from all that data, narrowing it down to a simplistic form that you will understand. And then it has just one output. That is powerful, if you ask me. The machine is becoming really powerful. And that is deep learning.
Question. From the right of you wrote that after choosing the number of hidden layers, so is there any hidden layer to this?
These layers,
They're all hidden.
they are all hidden.
Because they
They
don't
are choosing all this. This we are just
or it's like a simple one. It's like
it's not simple.
when I mean it's like it's not let's say you have like this long one now, say you have like two more. Are those like
No. This is a representation. This is a representation. Just like he was saying, there are some AI tools that are so complex. The kind of outputs they bring. What you are seeing here is times 10. You know what I mean? So when you talk about hidden layers, this we are just giving you an example for the purpose of introduction. We are just introducing it. But as you go in depth, you could not understand.
I'm trying to understand what you mean by hidden layer. The hidden layer, every layer in between input and output, but like there are specific layers that are hidden.
no. We call them,
Or,
Well, that's-
or everything in between the input and output is a hidden layer.
yeah. They are like actually, basically, they are hidden. I'll be able to answer that question more with a mathematical computation, maybe in the third class.
And then you will see why we say hidden. Because to you, it's not supposed to be hidden. It's there.
Yes.
You can see the process. So why are we calling it hidden? We know why we are calling it hidden. Are we okay? All right. So, any more questions? Any more questions?
After all the wahala and everything, I have soul product.
You have the product. No, but just think about it. You know, like I said, we always try to benchmark nature with machine technology. Okay? After all the wahala, just like you said, here is the human being. That is how the machine is. It's not even half as complex as human and nature. But we try. We have to try. Yes.
Deep learning, you said it's like an advanced machine learning with more
Layers, yeah, more functions.
would you say like deep learning now it's like machine learning, then maybe extra
No. Please continue. The noise behind you is what I'm trying to mitigate.
extra like functionalities like maybe speech recognition?
Yes.
all those
Okay. To answer that question, let's go. Okay. Where did I capture it now? All right, see. Demonstrates an understanding of advanced neural networks and understand application of deep learning, what you are trying to say. And then we are zeroing it down to computer vision. And then you can do speech recognition, text to speech, and so forth and so forth. And then you see various models, and then optimization will come into play, and finally we can understand deep learning in real-world applications.
I think that's the difference between it and reinforced, all of these extras.
The extras. Ma, do we have any questions from our virtual learners? No questions. Okay. So let's summarize and
Sorry, Maureen.
Okay, yes. How about processing power and especially implementation of AI function?
processing power. No, you have to bring. When we say processing power, we have you. What I try to understand there, the system that you use to apply these concepts or to run this kind of AI, they have to be powerful. You know, sometimes it's just like gaming. In the gaming industry, you know that there are some systems you cannot use to game. You can't use it to game because it does not have the capacity. The processing power is not strong enough. Same thing. By the time your system or your AI becomes more complex, you have to upgrade to meet. It will even tell you. There are some that you want to have. It will tell you that if you really read and you're careful about it, it will tell you that it supports this kind of system. So when it's not working well, you know that it's not working. Yes. Any other questions?
I have another question.
Okay.
It's not really related. It was mentioned in the last class about API. So I wanted to understand API more and like maybe the relation with AI.
That's a whole new topic. That's it. Do you want to do that now? Do you want to do that? Have a discussion with him. Or them, and then you look at API. Like, it's beautiful. You know, I told you everything is interconnected, right? And so he will discuss it, and then you will see her. Yeah. Good question. Okay, I want to call it. I want to summarize. Are we on the same page? It's like you guys got bored because I can see some people are gisting. So let me run. Our virtual learners, are you guys okay? Okay, so in summary, deep neural networks provide a powerful way of representing functions of machine learning.
And then another thing that we drew up, got from this class is that the weights and biases in each neuron allows us to control the behavior of the function, and that this behavior determines the loss with respect to our training data. You know, when I say loss, I hope you know what I mean, the loss function. Good. And then finally, the process of learning, I hope you know that it's machine learning. Learning of the machine, okay, fine, is to find parameters that minimize the value of the loss function. It's just grammar. I hope you know what we mean is that to make our predicted output as close to what we want as possible. That's what we mean. Are we okay with that? And finally, before I go, let me ask us, do we know the deep in deep learning? Okay, fine. So I'll see you in the next class.
Thank you, Ma. How do we get the materials?
Yeah, Ma, how do they'll get the materials, right? Upload the material. You'll get the material when it's uploaded, right? It's just my slides you get. Okay. You're welcome.
Someone said your class is intriguing.
Intriguing.
Yes.
Really.
Thank you. Please, can you just reply thank you? I said thank you. All right, thank you. Thank you very much. And this is interesting class to teach anyway.